And then, although this may seem like a small detail, with the deep learning model that you'll create needs to use numeric values as inputs for the different classes. This domain allows you to read or see readable values such as damaged or undamaged while feeding values of 1 and 2 into your training model for the deep learning tools to process. Then comes the step 5. Close the domain's views and fields value. Now that you understand how values are being stored, you'll ensure that the training samples polygons are properly classified. Then step 6, on the ribbon, click Edit tab in the section group, click Attributes as shown in the image. The attributes pane appears. You cycle through the features in this layer and update their attributes. Then the step 7. In the attributes pane, click the Layers tab. From the drop-down list, choose Training Samples. A list of features would appear. The first building in this is selected. Its attributes are shown below the list, just like shown in the image. You'll go through some of these buildings one at a time and confirm that the class value attributes reflects each building's current status. Click the step forward button to cycle through the buildings in this layer, this as shown in the image. Then in step 9, click the step forward button until you see the building with the object ID value of 8. The object ID value is listed on the attributes tab. If you look at the class weight attribute for this building and compare this to what you have seen on the map, this building has been incorrectly classified as undamaged. You'll correct this by editing the class value attribute. Then step 10. For the class attribute, click the drop down list and choose damaged. Note: if you do not have auto apply turned on, you'll need to press the apply button on the attribute pane for the saving purposes to auto save whatever you do. The sample for the feature changes to red, showing it's damaged. Buildings 9 and 10 have been incorrectly classified errors such as these in the training data will not necessarily break your model, but they will reduce its overvalue accuracy. You will update these buildings as well. Then in step 11, click the step forward button, edit the class value attribute for building 9, and then finally update the class attribute for building 10. Building 10 was incorrectly labeled as damaged. It should be labeled as undamaged. Then step 13, on the ribbon, click on the edit tab. In the manage edit tabs group, click save and click yes to save your edits. Then in step 14, close the attributes pane, and then in step 15, on the quick access toolbar, click save as shown in the image. Then comes export training samples for training the model later. A deep learning model cannot process the raw aerial imagery and training samples polygons. Instead, you'll split the image into smaller tiles called chips and convert the polygons to labels. These chips are smaller in pieces of imagery for the software to process, and the labels are different class of features that you identify damaged and undamaged. You'll use the export training data for deep learning geoprocessing tool to do this, and this have some steps you will have to follow. The step 1 is on the ribbon. In command search, type export training data for deep learning and choose export training data for deep learning. The geoprocessing pane appears. You will configure the tool to create the training labels. First, you'll select the imagery used to determine the class value for each building. In step 2, for input raster, choose USAA imagery 11/13/18. Next, you'll create a folder to store the results of this tool. And later, for the output folder, type buildings training samples. In step 4, for input features class or classified raster or table, choose training samples. For class value field, choose class value. The next set of parameters, tile size, is used to make the chips created by this tool bigger or smaller. You can change the size as per your requirement. The default size is 25 to 256 by 256 pixels. You'll make these chips larger. The stride value determines how much overlap there is between the chips that are created. By default, each chip overlaps by 128 pixels, but you can change it as per your requirement. Increased overlap will increase the number of chips created. You'll only update the tile size parameter as per your requirement. In step 5, for the tile size X and the tile size Y, type 448 for a better visibility and or a larger size, you can say. Now you'll set the format used for this project, type of image classification. Depending on your deep learning workflow, you'll choose the appropriate output format. That may vary from project to project. That depends on the nature of your project. Then in step 6, for metadata format, choose labeled tiles. Choose label tiles. Finally, you'll set the cell size for the tool to use. A deep learning model performs best when the training and prediction images are of the same resolution. Cell size is the dimension of image pixels in the real world units. For instance, if you're using a projected coordinate system with linear units of meters, setting the cell size to 0.3 makes each pixel in the output 0.3 meters wide. In the step 7, click the environments tab in your ArcGIS as shown in the image. And in step 8, under raster analysis for cell size, type 0.3. Then finally click run and save the project. Now you have exported a set of image tiles with the labels that identify the buildings as damaged or undamaged. You'll see these results to train a deep learning model to automatically identify buildings in each class. The first part of this lesson is over. Now is the second part, that is training the model. Now you'll train a deep learning model using the tiles you have created. Basically, now our preparation of data is complete. We have prepared our data, and now we are going to input that data into the model for its training. Depending on your computer's hardware, training the model can take up to half an hour or more. It's recommended that your computer must be or should be equipped with dedicated graphics processing unit GPU. If you do not want to train the model, a deep learning model has been provided to you in the project's provided result folder. Optionally, you can skip ahead to use train model to classify features section of this lesson. This is saying basically you need a GPU or a better performing GPU that will help you train the model. Because if you don't have a GPU or a better performing PC, your model will take a lot of time in training. So it's, if you don't have a GPU, it's better if you use the pre-trained model that is available on internet. Now train a feature classifier model. You'll use the chips that you exported before and labels you exported to create a deep learning model for classifying buildings as damaged or undamaged. These have some steps to follow. Step 1 is on the ribbon. In command search, type train deep learning model, choose train deep learning model. First, you'll set the exported training data from the previous section. Then in step 2, for input training data, click browse in your projects folder, select building training samples and click OK. Then in step 3, for output model, try buildings classify. Now you'll set the number of epochs for your model to train. Each epoch is one pass of all the training data forwarded and backward through a neural network. The more times you pass data through this network, the better your results will be. Although after a while, the returns from doing so will decrease, or you can say it will become static. In step 4, for max epochs, confirm that it is set to 20. Next, you'll choose the type of model to produce. This is based upon the format of your training data from the previous section. Then step 5, expand model parameters for model type. Choose feature classifiers. Object classification is another name for the feature classifier. Next, you'll set the batch size value. This parameter is the number of training samples that will be processed at a time. For batch size, type 8 in step 6, and in step 7 optionally, if your computer has a GPU, click the environments tab. For processor type, choose GPU. Otherwise, if you don't have a GPU, then leave it as is. Then in next step 8, click run and then finally save the. Before saving, in step 9, click view details, and in step 10, click messages to see if there are any generated warnings or any other messages sent by the compiler to you. For each of the epochs that run, messages display the model's performance. Especially, you'll begin to see the accuracy of the model increase or move toward 1. When training completes, you'll observe its results, and then in step 11, to close the trained deep learning model details window. Then in File Explorer in step 12, open the project folder, open the buildings classify folder. The folder contains a number of outputs that you can use to process imagery. Some of them are buildings classified.pth, that's a trained model. Buildings classified.emd is a model definition file that contains model information about the tile size, classes, and other details like model type. Model metrics.html contains a detail about the learning rate used and the final accuracy of the model. Buildings classified.dlpk is a complete package of all files stored in the model output folder, including the training model, the model definition file, and the model metrics file. This package can be shared to ArcGIS Online and ArcGIS Enterprise as an item for others to access. Next, you will explore the model metrics.html page to see how your model performed during the training. Then in step 13, open the model metrics.html file your default web browser opens. The trainings and validation loss section displays a graph of amount of error and other details about how the model and training of the model and its results are through, and it visualizes the output through a graph. Then there is a confuse matrix also used to observe how your model performed. And then in step 14, close the model matrices browse tab, and in ArcGIS Pro save this project. This is Now we will move to the third part of our lesson.